Have you ever stopped to think about how the internet, with its billions and billions of devices, hasn't just run out of addresses? I mean, it's a totally fair question, because it almost did. Today we're going to pull back the curtain on the really clever trick that saved the day: IPv4 subnetting.
You see, back in the early days, the internet just exploded in popularity, way faster than anyone predicted, and a huge crisis started brewing. The system that gives every computer a unique address, called IPv4, was never built for that kind of scale. We were literally facing a digital drought, just running out of IP addresses.
And this created what we now call the internet's great scarcity problem. The best way to think about it is like a digital real estate crisis. There's a limited amount of land, in this case IP addresses, and suddenly everyone on the planet wanted a piece. Without some kind of solution, the internet's growth was about to hit a brick wall.
But, network engineers are a pretty smart bunch, and they came up with this incredibly elegant solution. The answer wasn't to magically create more land, but to get way more efficient with the land we already had. They found a clever fix, and that fix is called subnetting.
So, what is it exactly? Well, at its heart, subnetting is kind of like taking one giant open field and dividing it up into a perfectly organized neighborhood with smaller individual lots. It's all about managing that space so that none of it goes to waste.
Okay, so how does this magic trick actually work? Well, it all comes down to a concept called borrowing bits. I know it sounds a little weird, but it's a remarkably simple idea that has a massive impact.
To really get this, let's ask a really simple question. How do you take just one big network space and, with one tiny little change, magically create two completely separate networks out of it?
The answer is hiding in the binary code of the IP address itself. So every IP address has two parts. A network part, think of that like your street name, and a host part, which is like the house number for each device on that street. Now look at this. We borrow one single bit from the host side and give it to the network side. And because that one little bit can be either a 0 or a 1, we've just instantly created two possible network addresses where there used to be only one. Just like that, two distinct subnets.
And here's what that looks like in the real world. That one borrowed bit splits our original network neatly into two smaller subnets. You've got subnet 0 and subnet 1, and each one has its own unique network address and its own dedicated range of addresses for all your devices. We've created order and efficiency out of just one block.
Okay, but what if two networks isn't enough for you? Well, the beautiful thing about this system is how it scales. If you need more, you just do it again. You just borrow another bit.
So when we borrow a second bit, we're not just adding one more network. We now have two bits to play with, which gives us four possible combinations, right? 0, 0, 0, 1, 1, 0, and 1, 1. And just like that, we've turned our original one network into four distinct subnets. It's exponential.
And this table shows you exactly how that plays out. We now have four subnets, all carved out of that same original block. Now you can give one to the sales department, one to engineering, one for your servers, whatever you need. It's all about efficient organization.
Now, this all sounds pretty perfect, doesn't it? But like with anything in engineering, there's always a trade-off. You never get something for nothing. And it's really important to understand what you're giving up in this deal. Here's the most crucial point to remember. Every single bit you borrow to create a new network is a bit you can't use for a device anymore. As the source material puts it so well, more subnets are available, but fewer addresses are available per subnet.
It's a classic balancing act, right? On one side, you gain more networks, which gives you incredible organization and efficiency. But on the other side of the scale, the more you subdivide, the fewer devices or hosts can actually fit into each of those smaller subnets. Okay, so let's say we've designed our perfect subnetted network. We built all these little digital neighborhoods. But how do we know if the roads between them actually work? Let's talk about checking your connections. Well, for that, we turn to the ping command. It is one of the most fundamental, most powerful tools in all of networking. It's basically like shouting Marco into the network and just waiting to hear Polo come back. It sends out a tiny little message called an echo request and just waits for an echo reply to confirm that the other side is alive and can hear you.
And there's a really logical way to use ping for troubleshooting. You always start small and then work your way out. So first, you check yourself. Then you check your immediate neighborhood, and finally, you check if you can reach the outside world.
Step 1 is always to ping this special address, 127.0.0.1, which is also known as localhost.
This test doesn't even go out over a wire. It's an internal loop inside your own computer that just confirms your networking software is running. It's basically the tech equivalent of asking, is this thing on?
All right, once you know your own machine is okay, the very next step is to ping your local gateway. That's almost always your router. This test confirms that you can successfully talk to other devices on your own subnet. Can you talk to your immediate neighbors?
And for the final test, the big one, you ping a remote host, something out there on the internet, like a big website. If you get a reply from that, you've just confirmed your entire connection is working, from your computer, through your subnet, out your gateway, and across the whole internet. So, let's do a quick recap. What are the big things to take away? First, subnetting was the genius solution to the internet's address scarcity problem. It works by borrowing bits to turn one big network into many smaller ones. The absolute core trade-off is that more networks means fewer devices on each. And finally, we can check that all our connections are solid using that simple but essential ping command.
And that leaves us with one last fascinating question. We now know how to create all these interconnected subnets, but when you send an email or load a web page, how does that data know the exact path to take to get from your subnet to another one, maybe halfway across the globe? Well, that's a story for next time.